So now we're ready to introduce the other two-sample t-test, the paired samples t-test. To introduce this one, I'm going to make use of those music preferences variables again. So if you're following along, as you should, you're going to want to change the filter back to the 1993 year filter, because again, that's the only year where we collected that music data. I had summarized it before, the independent samples t-test. The situation is that you've got one variable, two groups. But sometimes rather than testing whether different subsets of respondents vary on one attribute, you may want to test whether the same group of people are significantly different on two variables. Or sometimes it's two related cases and whether they differ. So within marketing research, where this is most common is sort of like the pre and post satisfaction kind of thing. So I could ask you, how satisfied were you with your visit today? And then you answer another survey 6 months from now, and I ask you, how satisfied were you with your visit then? And then you could say, were they significantly different at 2 points in time? And maybe, they've done a store remodel or something in between. Or, pre-COVID, how satisfied or how likely were you to recommend a service? And then after the pandemic, how likely are you to recommend that service? Did it have an effect? Was there a change? That sort of thing. So that would be a paired samples t-test. Another thing that you'll often see is you're asking someone to rate two brands that they use. And then you would say, okay, across this group of people, they use brand X and brand Y. Is their rating of brand Y significantly different than the rating of brand X? It's not the same thing as the independent samples t-test, because it's not two groups of people with one rating. It's one group of people with two ratings, right? So it's, you're kind of flipping things around a little bit. I seem to recall when I was an undergrad and I was introduced to the idea of paired samples t-tests, that the example that they loved to give was husbands and wives, and maybe it's because I was introduced to it in like a sociology of family course or something. But you can't treat husbands and wives as two independent groups. There's an expectation that husbands and wives living in the same household, or even brothers, sisters, their answers are going to be more similar than two completely random separate people, because they live in proximity, they have an affinity. And so even if it's not the same people being asked two different questions, it could be two groups of people who are related being asked a similar question. And you would treat that also as a paired samples t-test. But again, within marketing research, it's really more, you're the same person rates two brands, or I should say the same group of people rate two brands. Are they significantly different? So the paired sample t-test takes into account the dependence between the means being compared, whereas in the independent samples t-test, you would expect a bigger difference. So in short, it's basically smaller differences can result in significant findings with the paired samples t-test than would be necessary in the independent samples t-test. So we've got a group of people that rated a bunch of things, right? We can test if their ratings for country and blues music are significantly different. Now, an important thing to bring up is that you're only running this test on if a group of people provided answers to both questions. If you had, we have 1,500 people or so in this sample, and if 1,400 of them answered about country, but only 1,200 answered about blues, it's only those, maybe it's only 1,100 who answered both. Well, then your test is based on the 1,100 who answered both, because it's got to be the same group of people. So that's an important thing to keep in mind. All right, let me get out of this and go into the SPSS file again. The first thing I have to do again is change the filter, as I mentioned before. So I'm changing this to year equals 1993. I will paste that. Coming over here to my syntax file again, and I'm running the new filter. And so that should now have my file filtered for 1993 data. Good. We want to compare the ratings of country and blues. This one's actually pretty easy. I mean, compared to independent samples t-test, there's a lot less to worry about. We're going to go to Analyze, Compare Means again. This is under Paired Samples t-test. And you can see here, it's asking for a pair of variables. So I'm going to display the variable names. Again, I'm right-clicking to bring up that menu, in case you forgot. And so I'm going to click Country over, and that'll be variable 1. And then I'm going to click Blues over, and that'll be variable 2. And so this will now compare the ratings of country and blues and tell me if they're significantly different. That's basically it. Click Paste. Come over here to my syntax. And I run it. And now it will give you the means. Remember, in this one, a lower value means they liked it more. So if you wanted the story, it looks like on average, respondents liked country western music more than blues or R&B. But this was proposed as a two-tailed test. I wasn't hypothesizing that they liked one or the other, just are they different? Notice that the N, that's the number of people who are included in the sample, 1525. Blues also 1525. Those are the people that answered both questions. So there were 1,525. They give you a correlation here, and that's a very interesting metric, but we're not going to talk about that today. That is going to come up in the next module, where we'll talk about correlations. What we're going to focus on here is the paired samples test. Now you'll see there's a mean here. The mean is actually, it's the difference. The mean is the mean difference. Ultimately, we're just looking for this. Is that difference statistically significant? In other words, is this difference significantly different than 0? And we're getting 0.000. So again, our decision criterion is 0.05 or below would be significant. So this is significant. Their ratings of country western music and blues or R&B are significantly different. That's the answer. So no, I keep bringing this up, but I think it's worth mentioning. So we're implicitly treating the 5-point scales as interval level data by including them in this test. I keep mentioning it because I don't know, it's just a sticking point for me. I mean, a 5-point scale like this, I mean, really, truly, it's really ordinal if you're going to be like very strict about it. But it's important that you know in commercial marketing research, and even to some extent in academia, and not just within marketing, these attitudinal scales are used as interval level data. I mean, we actually do know that the space between 4 and 5 and 3 and 4 is not really the same. People don't use, like moving you from a 4 to a 5 versus the 3 to a 4 on a scale. There usually are significant differences in the distributions. But that's neither here nor there. But just know, as we've discussed, typically they will be treated as interval level data because it just allows us to do more things. Now, if we had hypothesized that one genre was preferred more or less than another, it's the one-tailed thing again, right? Same approach. Are the means in the right relation? And then if they are, you find your two-tailed sig value and you divide it by 2. So, I mean, we're ready for an exercise already. So let's move on to exercise 8. Evaluate the following hypotheses. Respondents demonstrate the same preference for opera and classical music. Respondents prefer contemporary rock to heavy metal. Respondents prefer jazz over folk music. So before I ask you to pause and go ahead and do it, I will just say one thing. You don't need to run each pair, like you put in a pair and then you paste, and then you switch the pair and you paste. You can do it that way, but you actually can put in multiple pairs at the same time. So feel free to do it either way. Pause the video, give it a shot. When you're done, come on back and we'll go over it. And welcome back. Let's take a look. We're going to go to Analyze. Compare means, paired samples t-test. Now, we had been looking at country and blues. I'm going to take those out. The 3 pairs that we were given here were opera and classical. So I'm going to pull over opera first, and then classical. And notice, it does matter when you pull them in. Like, I have to put in the first pair before I move to the first variable in the next pair. You can just grab things and drag them, but I find that gets a little bit tricky. Contemporary rock and heavy metal. So con rock is contemporary metal. So I can grab this, I can drag it over here. and then heavy metal. You want that red line to appear underneath, otherwise you'll end up swapping things out. So you can do that too. But normally I just like to do this. I'll just click it over jazz and then folk music, and I got my 3 pairs. Just paste. Now, if you come over here to the syntax, you'll see that the way that gets put in here is they put them in respective order. So it's opera with classical, con rock with heavy metal, jazz with folk. So that's the way that the pairs are listed in the syntax. You never need to write this on your own from scratch. You can always use the menus to create it. So I don't want anyone to feel stressed out about they need to learn how to write the code. I think it's very useful for you to learn how to manipulate the code because it'll allow you to do things faster. But I don't think it's important that you know how to write it when you have the menus available. I mean, they're there. I use them all the time. And sometimes it's faster to use the menus to create the initial syntax, and then I just copy and paste and edit. Okay, I'll hit run selection. And you'll see we get 3 pairs. Now, if you ran 1 pair, swapped it out, the output would look a little bit different. It would be 3 sets that look like this, just one after the other. When you run multiple pairs, it just throws them all together like this. Remembering, again, that lower value means that they like it more. Our first hypothesis was that respondents demonstrate the same preference for opera and classical. Two-tailed test, right? So we only need to see if they are significantly different. I come down here, two-tailed, significant. Okay, moving on. Respondents prefer contemporary rock to heavy metal. So that was a one-tailed hypothesis. 2.66 for contemporary rock, 4.11 for heavy metal. Again, lower means they liked it more just because that's the way the variable was coded. So the means are in the right direction. So we would have to divide this by 2 ultimately, but we are going to get a chance to look at it. It's 0.000. It's everything significant. Respondents prefer jazz over folk music. Jazz actually has the lower value, so it is preferred again, and it is significant. So those are the 3. Now, if I had said respondents prefer folk over jazz, the answer would be no, and we never even look at this because the means are in the opposite direction. So that wraps it up for our paired samples t-tests. In the last video for this module, we will look at the analysis of variance.